We are doing day 1 of graphing exponential functions, and you are going to absolutely need a calculator today. So if yours is not handy, go ahead and pause this video and go find it. Okay, so what is an exponential function? An exponential function is any number raised to the x power except for 1. We do not include 1 to the x power in the category of exponential functions because 1 raised to any power is always going to give us a result of 1. And if we were to graph that, that would just give us a horizontal line. So it does not really fall into our category of exponential functions because of that. So how do we evaluate exponential functions? Well, if we have 2 to the x power as our function, when x is -4, you're simply plugging in -4 in place of x. So if this will focus, we got 2 to the -4, which if you recall from not too long ago, goodness, there we go, not too long ago, to make an exponent positive, we move its location, and 2 to the 4th power is 16. So that would be 1 over 16. Then if x was 6/7, we're looking at 2 to the 6/7 power. Now that's the same thing as the 7th root of 2 to the 6, which is kind of hard to figure out by hand, so we can plug that into our calculator. 2, this little arrow is our exponent key to the 6 divided by 7. That's going to be about 1.81. And then 2 to the pi power, I'm going to raise 2 to the, and this button is also where my pi is, so second caret top gives me pi. And so that is about 8.82-ish, give or take. On to the next one, 1.085 to the x power. If x is 0, that's 1.085 to the 0 power. Anything to the 0 power is 1. If x is -0.1, that's going to be 0.085 to the -0.1 power. And I'm going to use my calculator for that. So here we go, 1.085, caret top, -0.1. Make sure you're using the negative and not the minus button. And that is about 0.99. And then square root of 2, that is going to be 1.085 to the square root of 2 power, 1.085 caret top, and this time I need to look for my square root function, and that is here. So second, the x squared button, 2, and that is going to be 1.12, give or take. You know, we're estimating, we're rounding here. All right, last one of this kind, 500 over 1.02 to the 5x power. So if x is 1, that's going to be 500 over 1.02 to the 5th power. So again, I'm going to use my calculator for that. 1.02 to the 5th. And that is about 452.87. If x is 8, that's going to be 500 over 1.02. 5 times 8 is 40, so that's going to be the 40 power. 500 divided by 1.02 to the 40th power, and that gives us 226.45. And then if x is 25, I'm going to get 500 over 1.02 to the 25 times 5 is 125. So 500 divided by 1.02 to the 125 power, and that gives us 42.07. Now, what's really the takeaway here today is the graphing. So we know how to plug things into our calculator and solve by hand, but graphing is what we're really going to take a look at. So here in this graph, I have 2 functions, 2 to the x power and 4 to the x power. We are going to figure out which belongs to which. So what I'm going to do is fill in this table with my calculator. So in my y1, I'm going to put 2 to the x, and in my y2, I'm going to put 4 to the x power. And if your table set is not already on ask for the independent, fix that. And we are going to type in those values, -2, -1, 0, 1, 2, and 3. And we are going to fill in our table. So remember, y1 is 2 to the x, y2 is 4 to the x. So I'm going to fill in my table. Okay, so now I need to identify between the two. So I am going to say that this is my yellow, the 2 to the x, and 4 to the x is my green. So looking here, they both cross through the y-axis at 0, 1, And I'm given some of the other points. So I've got one of them as being -1, 0.5, and the other one being -1, 0.25. So when I look at my -1 in my table, the one that gives me 0.5 would be my 2 to the x, or my yellow. So this darker function is 2 to the x, which means our lighter function is 4 to the x. Okay? So 2 to the x and 4 to the x. Now, if we go on to the next page, we are doing a similar process, but we are looking at now 2 to the -x and 4 to the -x. Excuse that bell. And we are going to be filling in our table, so I need in my y1 to change this to 2 to the -x, and in y2 change that to 4 to the -x, and go back to your table, and we're plugging in those same values. Again, y1 is 2 to the -x, y2 is 4 to the -x, so 4, 1. So plugging in these values, again, I need to identify which is which. So they both still cross through the x-axis at 0, 1, sorry, the y-axis at 0, 1. And now looking on this point here, I've got 1, 0.5 and 1, 0.25. So looking at +1, the 0.5 belongs to my 2 to the -x, so that's again our darker function. And so our lighter function is going to be 4 to the -x. So 2 to the -x, 4 to the -x. So between the graphs on the front and this one, what we see here is a reflection over the y-axis. So we are going to be looking at transformations again here for these functions today. So comparing the graphs we made on the front and the back. Domain and range. For both of these, our domain is all real numbers. X can be anything. There's no restrictions. In our range, our y values is going to be all positive numbers. It's all above the x-axis, all positive y values, and it never quite touches 0. What happens to our y values as x increases? So looking at our graphs on the front and the back separately, if I'm looking at my graphs on the front, as I go from left to right, my y values are getting bigger. We call that an increasing function. If I look at my graphs on the back side, as I go from left to right, my y values are getting smaller, so that would be decreasing. So for the ones on the front where it's just x, we have increasing, and the ones on the back, we have decreasing. Okay. So what does the x-axis act as in each of these functions? Well, our graph is getting really, really close but not quite touching, and remember we call that a horizontal asymptote. So it is acting as the horizontal asymptote. And for all of these functions that we've seen where it crosses the y-axis is at the point 0, 1. Remember, this is a location on the graph, x, y. You need to list it as an ordered pair. Okay. So what exactly is happening when we're changing these numbers? So if I'm looking at a to the x power, I want to compare 3 graphs at once, 2, 3, and 5. So let's go back to our y equals menu. We're going to put 2 to the x in y1, 3 to the x in y2, and 5 to the x in y3. And we want to look at it in this window. So if you go to your window settings, you're putting in your x-min, x-max, your y-min, and your y-max, and then we're going to graph these. And I am just going to kind of roughly copy them down onto my paper. So this was the blue is at 2, the red is 3, and the black is the 5. So I'm just going to roughly kind of give a rough overview of what these look like. They're increasing. They're all crossing the y-axis at 1. So when the number changes, I'm going to look first at these things on 2. For all 3 of these graphs here, our domain is all real numbers. Our domain has not changed. Our range is all positive numbers. The y-intercept for all of these is still 0, 1. They are all increasing. And there is a horizontal asymptote at y equals 0. What's changing here is like the steepness, right? the rate of increase. That is the only difference here when we're changing our base, 2, 3, or 5. Okay. Let's do the same thing here, but comparing to the negative x power. So I'm going to go back in here and change these to 2 to the negative x, 3 to the negative x, and 5 to the negative x. We're keeping our window the same. Woo. Come on. Focus here. There we go. So there are our 3 graphs. Again, I'm going to copy these down. We've got blue, red, and black. So our blue, our red, and our black. Again, these are just super rough sketches. So comparing these 3 graphs, our domain and range for all of the graphs, these 3 graphs, our domain is still all real numbers. Our range is all positive numbers. Our y-intercept, they all cross the y-axis at 0, 1. These are all decreasing, and we still have that horizontal asymptote at 0. So again, what's changing here is that just the steepness. In this case, it's the rate of decrease. That is what's changing when we are switching the base. Okay, so to summarize, when we have a to a positive x, our domain is all real numbers, our range is all real positive numbers, and we have a y-intercept at 0, 1. It's increasing, horizontal asymptote at y equals 0. Then when we have a raised to a negative exponent, we have all real numbers in the domain, positive numbers in the range, same y-intercept, decreasing, horizontal asymptote at y equals 0. What changes here is our graph goes from an increasing function to a decreasing function. That is the change when we go from a positive x in our exponent to a negative x in our exponent.